In order to operate this coffee maker at the US standard 120 volt, the friend needs to use a step-up transformer to convert 120 volts AC to 240 volts AC, and then we use that equation at the number of coils in the transformer over N1, right? We need to find that, and we will use the fact that the average power is equal to VRMS times IRMS. And N2 over N1, if you remember, is V2 over V1, which means this is 240 volts over 120 volts, which is 2. That means the secondary coil has twice as many turns as the primary coil. Part B, we're asked what current will the coffee maker draw. Let's call I1 the current in the primary, so P average would equal V1 I1, and P average would also equal V2 I2, secondary and primary for 1 and 2. We're going to assume there's no loss of energy in the transformer, so we can say that I1 is going to be P average over V1, and we're told that it has 960 watts over the first voltage of 120 volts. That gives us 8.0 amps. The secondary current I2 then is equal to P average over V2, which is 960 watts over 240 volts, or 4 amps. In part C, we're asked what is the resistance of the coffee maker. We know that R1 would have to equal V1 over I1, so that's 120 volts over 8.0 amps, which is 15 ohms, and R2 would equal V2 over I2, which is 240 volts over 4 amps equals 60 ohms. Another way we could have done this is that R2 would equal N2 over N1 squared,